No, I mean, it's fine. I agree.
Sure it's facing the right way. That GPS light, come on.
My name is Ed Herring. I work at the NASA Armstrong Flight Research Center, and I'm the principal investigator for the Carpet Diem Phase 2 flights. So Carpet Diem stands for Carpet Determination and Entirety Measurements. When a plane flies supersonic, the booms come down and hit the ground in the area we call the sonic boom carpet. So we want to grab the entire carpet or seize the boom. And we're trying to evaluate how our new sensors, the ground recording system, GRS, works, preparation for the X-59, and also test out some new systems to remotely turn them on and off in the field. We're going to have about 150 of these in the field for tests with the X-59, and that's a lot of people to staff, so we want to make them more automatic. Carpe Diem is a risk reduction getting ready for X-59, trying to get that remote triggering of our recording system. We tested 2 different systems. One was called Thor, and Thor allows us to use the transmissions from the aircraft saying the aircraft is at a certain place, certain altitude, speed and direction. We take that information and compute when the sonic thump is going to hit and use that to turn our recorders on or off. We did 4 flights. We did 21 supersonic passes, headwind, tailwind, straight overhead, way off to the side, to really exercise the capabilities of these systems. In Carpe Diem Phase 1, we deployed a lot of sensors over a 30-mile array, trying to figure out how long it took us to get out there, set up all our equipment, and be ready for the planes to come over. So it was more of a logistics test, whereas Phase 2 is more focused on the sensors themselves. How do they record? How can we get them to remotely turn on and off? For Carpe Diem Phase 2, a typical day was we would set up our microphones out in the field. We had a station for microphones every 100 feet, over 1,600 feet. And we had both the GRS and other microphones that we've been using in the past, kind of a head-to-head test of the new system to our existing system. We would, before the flight, get the weather of the day, plan out when the booms would hit and the exact flight conditions the pilot had to achieve to get the booms where we wanted them. Communicate that to the pilot. Pilot would fly those flights, and about every 5 minutes we'd get a boom on our array, and we get 5 or 6 passes per flight, and then a lot of data to collect and analyze and coil up all the cable and get ready for the next day. Carpe Diem is really important to work out all the logistics and all the hardware problems we're eventually going to have, get them out of the way now so that when we're ready for X-59, there are no hiccups. We're developing new hardware and new software techniques, new logistical techniques to make sure that when X-59 flies, we're ready to get all the data from day 1.